Good morning, students. Welcome to your chemistry class. So, today we are going to start with the third point, which is under carbon dioxide and the environment action on natural water. It is on page number 105 of your book. So, please open this page. So, natural water is slightly acidic to slightly alkaline. That is, it is having pH between 6.5 to 8.5. We say the pH 7 to be neutral. So, it is slightly acidic and slightly alkaline. pH is a measure of the acidic or alkaline nature of a dilute solution. So it is measured with the help of a pH meter or a pH paper. For your reference, an image has been attached of a pH paper. You can see this. These are the strips of a pH paper which we put in the dilute solution that we are having, and it shows the color change from which we can see it is an acidic or a alkaline solution. Pure water is neutral, that is neither acidic nor alkaline, and has pH 7.0. Acidic solutions have pH less than 7, that is if it is showing pH from 1 to 7, less than 7, it will be acidic, and if it is showing pH more than 7 like 8, 9, 10 up to 14, so it will be basic. You know that on dissolving in water, carbon dioxide forms the weak acid that we have seen, carbonic acid, which is having the formula H2CO3. So, the gas tends to bring down the pH of water that is open to the atmosphere. For drinking purposes, slightly acidic water is better than alkaline water. Acidic water pH 6.5 is soft and palatable, but alkaline water that is of pH 8 is hard and unpalatable. Also, the pH inside our digestive system is acidic. So what it is trying to say is that if the drinking water is slightly acidic, then our body can tolerate it. If it is having pH 6.5, our body can tolerate that water. But if it is on the alkaline side, that is, it is having pH 8, our body cannot tolerate it. So this shows that slightly acidic water we can have, but the basic ones it will not be suitable for our body. They are saying also the pH inside our digestive system is acidic. There is a acid present in our stomach, so that is why the pH of our digestive system is also acidic. On the other hand, marine organisms thrive better in alkaline water than in acidic water. So, for marine organisms, it is the reverse case. They thrive better, they live better in alkaline water and not in acidic. And it has been found that the increasing proportion of dissolved carbon dioxide is lowering the pH of seawater. It means it is turning the seawater acidic. This is posing a threat to marine life because they will not be able to thrive in the acidic water. Next, they are telling us about uses of carbon dioxide. First is carbon dioxide is used in the industry for the manufacture of metal carbonates, hydrogen carbonates. This all we have seen with examples and chemical reactions also. Second, urea. Third, ethanol. Second is it is used in fire extinguishers that we have also seen because it is heavier than air and it displaces the air from that place, and by that the fire extinguishes. It is extensively used for making soda water and fizzy drinks. Fourth, in welding, carbon dioxide is used in order to prevent the oxidation of metal by air. So, this is used in welding also. Fifth, in the form of dry ice, carbon dioxide is used as a coolant and for depicting smoke in plays, movies, and so on. We have seen that dry ice directly sublimes, so it can show the properties of smoke also if it is present under certain conditions and we bring it out, so it will directly sublime and not turn into liquid, and it will give the effect of smoke. How a fire extinguisher works is our next topic. So, they have shown an image of a fire extinguisher. We will see how it is working. Common fire extinguishers produce carbon dioxide by the action of sulfuric acid on a solution of sodium carbonate or sodium hydrogen carbonate. So what is happening is they have taken the solution. Over here you can see it is sulfuric acid. Here sodium carbonate solution is there. So the reaction that is taking place is this one. We are having sodium carbonate over here and it is reacting with sulfuric acid giving sodium sulfate, water and carbon dioxide. If we are having sodium hydrogen carbonate, it will on reacting with sulfuric acid, it will give sodium sulfate, water and carbon dioxide. By this way, using both of these, we can see that carbon dioxide is formed which will help in extinguishing the fire. A solution of sodium carbonate or sodium hydrogen carbonate is placed in a fire extinguisher. A sealed bottle containing sulfuric acid is also placed there. This one. This is the sealed bottle that is containing sulfuric acid. In case of fire, the acid bottle is broken by striking the plunger against a hard surface. This is the plunger that they are talking about. So what they are doing is this is a sealed bottle and when there is a fire, we have to extinguish it. Firstly, you have to break this plunger by striking any hard surface. The acid reacts with sodium carbonate or sodium hydrogen carbonate and carbon dioxide is formed. A mixture of water and carbon dioxide gushes out, which is directed towards the burning object. Carbon dioxide, being heavier than air, surrounds the burning object and cuts off the supply of air. As a result, the fire is put out. So, this is basic. What is happening is that we are having a plunger over here that we have to break in case of a fire, and when this is broken the sulfuric acid reacts with sodium carbonate and water and carbon dioxide comes out of the nozzle which help in extinguishing the fire. Next is carbon monoxide. Carbon monoxide is a common product of the combustion of carbon-based fuels. Being a poisonous gas, it pollutes air, but at the same time the gas is used for many industrial purposes too. So we will look into both these aspects of the gas here. We will see how it is a poisonous gas and it is polluting air, but on the other hand, it is also helpful in many industrial ways. So, poisonous nature of carbon monoxide is our first topic. Let us see how the gas affects us and how we can get rid of its effects. Concentration of carbon monoxide. The concentration of a substance expected to be present in very small quantities in a mixture is often expressed in parts per billion. That how many parts of that substance or whatever we are taking are present per million other parts. So parts per million. This tells us the number of parts of a substance present in 1 million parts of the mixture. The concentration of carbon monoxide in air is also expressed in parts per million. For example, a carbon monoxide level of 100 ppm in a congested city indicates that 100 liters of carbon monoxide is present in 1 million liters of air in that city. The carbon monoxide level in cities generally varies from 5 to 100 ppm. So here they have explained you about parts per million and how much carbon monoxide is present in cities. So next is how does carbon monoxide affect us? As you know, blood transports oxygen in our body. When we inhale air, the oxygen of the air combines with hemoglobin of the blood to form oxyhemoglobin. So what is forming is whenever we inhale air, the oxygen that we are breathing combines with the hemoglobin of our blood and it forms oxyhemoglobin. Oxyhemoglobin runs through blood vessels and gives up its oxygen to cells which use it for respiration. But carbon monoxide displaces oxygen from oxyhemoglobin to form carboxyhemoglobin. The affinity of carbon monoxide for hemoglobin is 325 times greater than that of oxygen. So, the displacement takes place easily. Affinity means that carbon monoxide is 325 times greater attracted towards, we can say, hemoglobin. Their combining capacity is 325 times greater than oxygen. So the displacement is taken easily. The formation of carboxyhemoglobin cuts off oxygen supply to cell. Here we are saying that if oxygen is combining with hemoglobin, oxyhemoglobin is formed. But if carbon monoxide is displacing oxygen from the oxyhemoglobin, then what is forming is carboxyhemoglobin. And this carboxyhemoglobin cuts off oxygen supply to cells. That means our cells will not be getting the oxygen. Therefore, adverse effects are seen. The severity of the symptoms depend on the amount of carbon monoxide in the blood. Inhaling air with a high carbon monoxide level may even be fatal. A person may die of asphyxia in an environment of carbon monoxide. So one should not sleep in a closed room heated by a coal fire, because maybe it will lead to the formation of carbon monoxide, and in your blood it will be forming carboxyhemoglobin, and it may lead to the death of the person who is sleeping in such a room. Beta asphyxia is a condition in which your body is not getting the amount of oxygen it needs. That is, there is some deficient supply of oxygen, which we have seen that how it affects our body if we inhale carbon monoxide. So that is the condition of asphyxia. So effects of carbon monoxide poisoning, they have shown you that how much amount of carbon monoxide present in parts per million can have the effect. So if there is 100 parts per million of carbon monoxide, it will lead to headache, disorientation. If it is having 300 parts per million, there will be loss of consciousness. 600 will lead to coma, and 800 will lead to the death of the person. Curing carbon monoxide poisoning. Carboxyhemoglobin slowly loses carbon monoxide on being exposed to an excess of oxygen, and oxyhemoglobin is again formed. So the same is, if we are giving the proper supply of oxygen, we are giving excess oxygen, then in our body oxyhemoglobin will be again formed. So a person suffering from carbon monoxide poisoning should be kept on oxygen till he or she recovers, so that the carboxyhemoglobin is displaced with oxyhemoglobin. So we have seen the harmful effects of carbon monoxide. Now we will be seeing how it is helpful in industries. Industrial uses of carbon monoxide. Carbon monoxide is an industrial gas. Some important uses of this gas are given below. First is, it is used as a reducing agent in metallurgy. It can abstract the oxygen from many metal oxides and set the metal free. If we are having a metal oxide, here M represents a metal, and it reacts with carbon monoxide. On heating, the metal will be extracted, and the second product form will be carbon dioxide. For example, the mineral bauxite, which contains Fe2O3, is reduced by carbon monoxide in a blast furnace to give iron. So we are having iron oxide, and it is reacting with carbon monoxide. On heating, the iron oxide will be displaced, and we will be getting carbon dioxide. So what we were having is Fe2O3, iron 3 oxide, and what we will be getting after reaction with carbon monoxide, we will be getting iron 2 oxide. Third, if iron oxide reacts with carbon monoxide, again we are heating it, it will lead to the formation of iron plus carbon dioxide. Second use is carbon monoxide is also used in metallurgy for the refining of nickel. Third, it is used on a large scale in the industrial preparation of several organic compounds such as methanol, acetic acid, hydrocarbons and phosgene, that is COCl2, used in the synthesis of some polymers. Our next topic is fuel, which we will be doing in our next video. Thank you, students.